just have the sheet. Here we go. I have the sheet in front of me. No, I don't have the sheet in front of me. Okay, hopefully this is it. I hope I have the right sheet. I need my glasses. Well, hopefully you guys are all waiting for that snow to come because it's coming. 9 is negative 3x greater than 3. So we're going to divide both sides by negative 3. And remember, if we divide both sides by negative 3, by a negative number, we have to make an adjustment, right? Because negative, and then that becomes negative 1. Our number line looks like this. Our solution, the graph for solutions could be negative 1, 0, negative 2. Only one number is less than negative 1, which is this way. You can check, pick any number you want. Our original inequality is this. So I'm going to pick, I don't know, let x be negative 10. 3 times negative 10 is greater than 3. 3 times negative 10 is positive. And you can tell that works. So we are good. Somebody has to remind me that when I give you home check understanding, I'm also giving me check understanding. Somebody should stop me. 13, negative 1 less or equal to v minus 2 over 21. The easiest way to do this is to get rid of the denominators. Let's multiply both sides by 21. That gets rid of that. I get negative 21, v minus 2, plus 2 on both sides. That goes away, and I get negative 19, which I can graph. Negative 18, negative 20. It is shaded because negative 19 is part of my solution. So negative 19 is less than all these numbers. So if you don't know which way to point, I suggest you pick a number like an extreme number. Pick 1,000, just to exaggerate a little bit, and see if that's true. Is negative 19 less or equal to 1,000? Yes, it is. And where's 1,000? 1,000 is to the right of my number line, so we want. That's the solution, right? Any number to the right of negative 19, including negative 19. So, negative 1, blah, 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 v minus 2 over 21. And for your check, now, remember I told you, if you can pick 0, please do so. It will make life much easier. So I'm going to make v equal 0, so because 0 is part of the solution, right? One of the numbers that is part of my solution. So I substitute, and I get 0 minus 2 over 21. Negative 1 is 0 minus 2 is negative 2. Oh, maybe that was not well. So negative 1 is less than, and negative 2 over 21, I don't think picking 0 on this one was a good idea, but 2 divided by 21 is 0. Negative 0.095, which is definitely, negative 1 is definitely less than that. I think better off pick a number like 23 would have been better, right? Making v equals 23, because when I subtract 23 minus 2, I've gotten 21, and that would have been an easier thing to do. Okay, so something to consider when you substitute. 0, I apologize, was not the best choice here. 16, where's 16? Negative 90 greater or equal to negative 5k minus 3. Negative 90 greater or equal to negative 5k plus 15. We're going to subtract 15 from both sides. And we get negative 105 greater or equal to negative 5k. Divide both sides by negative 5. And we get, oops. And because we're dividing by a negative number, we're going to switch the the inequality sign. And that's a positive, which is 26. No, 21. Number line. 21 is less than all these numbers. So, again, pick a number here just for you to figure out which way to point the arrow. And 21 is less than 1,000, or which means that we want numbers to the right. Every single number to the right of 21 makes that inequality true. Let's pick an easy number. Let's make k equals, I don't know, an easy number. 23. Let's make it k equals 23. So negative 90 greater or equal to negative 5, and then if we substitute here, we get 23 minus 3. Negative 90 greater or equal to negative 5, and 23 minus 3 is 20. That's easy to multiply now. That's negative 100, and negative 90 is definitely greater than negative 100. So, again, we are good. I forgot what the next number is. 21? What did I just do? 21 and 23. Okay, 21, 84 greater or equal to negative 7, v minus 9. 84 greater or equal to negative 7v plus 63. We're going to subtract 63 from each side. And we get 21 over here greater or equal to negative 7v divided both sides by negative 7. Switch the the inequality sign. And 21 minus divided by negative 7 is negative 3. Number line, negative 3, negative 2, negative 4. Negative 3 is less than all these numbers. So shade. And let's see which way we point. So again, I'm going to put 1,000 here. So negative 3 is less than 1,000, that's for sure. So 1,000 is to the right on the my number line, and that's where I'm pointing. For this one, you definitely want to pick 0. 0 would actually be a nice number. So v equals 0, so my check. 84 is greater or equal to negative 7, v minus 9. 84 is greater or equal to negative 7. I'm going to put 0 over here. Actually, I should have picked 9. My apologies. So 0 minus 9. 84 is greater or equal to negative 7. 0 minus 9 is just negative 9. And if I multiply those two, I get 63. So actually, the better number here would have been v equals 9, because then 9 minus 9 would have been 0, and everything else would have been 0. It's much easier to do, but it doesn't matter. 23, x, negative 6, minus 8, and 12. So you don't have to clear the fractions here. This is not one where you have to. You can. It actually wouldn't work. Well, you can. I wouldn't. With the plus 8 on both sides. This is 20. These go away. X divided by negative 6. We're going to multiply both sides by negative 6. Right? 20 times negative 6 is negative 120. Negative divided by negative gives me a positive. 6 divided by 6 gives me 1. And x over 1 is just x. So we want all the numbers that are less than negative 120. And where are we going to point? So negative 120 makes that inequality true, and every number to the left of it also makes it true. What number should we pick? I want to pick definitely a number divisible by 6. So here's my check. Right, so let me pick a value for x. 120. Let's pick 180. So let's make x negative 180. Because negative 180 is over here. It's part of a solution. So if I substitute, I get negative 180 over negative 6 minus 8, less or equal to 12. Negative divided by negative. Hang on a second. Oops. I forgot to switch the sign. Oh, that's why it's not working. So let me go back here. I multiplied both sides by a negative number, so that should have gone that way. Shade, still shaded, but we want numbers greater than negative 120, which is going to go that way. Now I'm going to switch my number, and I'm going to select x equals 0, right? Because 0 is part of my solution, right? So x divided by negative 6 minus 8, less or equal to 12, and then I get 0 divided by negative 6 minus 8, less or equal to 12, and this one works out nicely. 0 divided by negative 6 is 0, minus 8 is negative 8. Less or equal to 12, and that's true. Now we go for that last page. And hopefully I didn't select too many. Oops, I did. 16, 17, 18, 20. Oh my god. 16, negative x, 16, 17, 18. All right, 16, 17, 18. All right, let's look on that. Negative x less or equal to negative x plus 7x minus 2. So this is one where I can want to pick 0 if possible. So negative x less or equal to than x. Do the street properly. I get plus 7x minus 14. I combine like terms. This becomes 6x minus 14. I have variables on both sides. One of them I want to throw away. I'm going to throw out the negative x plus x here plus x here. This goes away. I get 0. And this becomes 7x minus 14. I add 14 to both sides. 14 less or equal to 7x divided by 2. And I get 7 less or divided by 7. Oh my god. Oops, take a step back here. Divide both sides by 7. Apologies. 14 divided by 7 is 2, less or equal to x. Graph that. So 2 is less than all these numbers. So 2, 3, 1 is not shaded. And obviously 2 is less than the numbers that are on this side of the world. Well, no easy number here to pick. Well, let's just pick 3. Let's make x equals 3 and substitute. So I would get negative 3. So actually, I'm going to write this down because this one. So negative x less than negative x plus 7 x minus 2. So if I replace the 3 with x, I get this. 3 minus 2. That doesn't do anything, and oops, I forgot to substitute this with 3. Let's see, inside the parentheses, 3 minus 2 is 1. 1 times 7 is just 7, so I get negative 3 plus 7. Negative 3 is less than, and negative 3 plus 7 is 4. And that is a true inequality. Now 16, 17, negative 5n plus 6, yikes. 5n minus 6 minus 6n, please. 0 would be nice here again. So first things first, get rid of the parentheses. So you get negative 35n plus 42 minus 6n. Combine like terms, nothing on the left side, but I can combine some terms on the right side. Negative 35 and negative 6 gives me negative 41n plus 42. There are variables on both sides. Let's get rid of the negative 5n by doing plus 5n on both sides. That goes away. 6 days. This is what is that? 36. Negative 36n plus 42. We're going to subtract 42 from this side and subtract 42 from this side. That goes away, and I'm left with negative 36. Divide both sides by negative 36, and I won't forget to switch the sign this time. Negative and negative goes away. Positive 36 divided by 36 is 1, so I get n on this side, and here I get positive 1. Let's draw the solution on the number line. We got 1, 2, 3. Oops. 0. Shade, not shade, and 1 is less than all these numbers. Well, obviously 1 is less than every single number that way. Let's pick a easy number. Well, there is no easy number, everything. So let's pick n equals 2, positive 2, and let's just substitute. So I get negative 5 times 2 plus 6 greater or equal to negative 7. 5 times 2 minus 6, and then minus 6 times 2. Yuck. Let's see, negative 10 plus 6, I get negative 4. So that was easy. On this side, it's negative 7, and inside the parentheses, 5 times 2 is 10. 10 minus 6 is 4. And then minus 6 times 2, which is 12. Negative 4 greater or equal to negative 4 and 7 is negative 28 minus 12. Negative 4 is greater or equal to negative 40, and that is a true inequality. So everything is okay. What was that? -5 and 18. Okay, 16. Okay, I have my numbers on my phone. So 18, 3p minus 3, -5 minus 5p, -3p minus 6. Okay, 3 property, 3p minus 9 minus 5p greater than -3p minus 6. Combine like terms on the left side. This guy and this guy gives me -2p minus 9. Variables on both sides. Let's get rid of the small one. I'm going to get rid of a 3p. You get rid of whichever one you find better for you. -2p and 3p is p minus 9 greater. This goes away. Minus 6. Plus 9 on both sides. And p is greater than 3. Oh, no. Oh, no, no, no. Alright, so number line. The solution to this are all the numbers greater than 3. We're going to point that way. I'm going to... jeez. Well, let's select p equals 4. No point picking a number higher. So we get 3, 4 minus 3. So this is my check. Minus 5 times 4 greater than -3 times 4 minus 6. So this is 4 times 3 is 1. 4 minus 3 is 1. Times 3 is just 3. Minus 20. On this side, -3 and 4 is -12. And then you're going to subtract 6. This gives me -17, which is greater than -18. Very, very true. Okay. What was that? 18? All right, so now it's 20, 21, 22, 23, 24, 20, yuck. 20, oops. 28 minus 7x less or equal to -4 and -7x minus 7. Okay, 28 minus 7x less or equal to 28 positive, 28x positive plus 28. Right? Yep. I have combined like terms, no, but I have variables on both sides, so let me get rid of 7x over here, and I'm going to do 7x over here. That goes away. Left is 28, less or equal to 35x plus 28. Minus 28, minus 28. That becomes 0, less or equal to 35x. Divide both sides by 35. And x is less or equal to 0. Oh, nice. So, 0, 1, -1. Shade, because 0 is part of your solution, and 0 is less than all these numbers, and 0 is less than numbers on the right of 0 or equal to 0 in this case. So we can pick 0, which is a good thing for our check. So for the check, I'm going to say let x equal 0. So I'm going to go 28 minus 7 times 0. Less or equal to -4 minus 7 times 0 minus 7. Well, 7 times 0 is 0, so that's just 28 on the left side. Less or equal to, and over here, let me put the -4. -7 times 0 is 0. 0 minus 7 is -7. And 28 less or equal to 28. And again, that works out. 21. Okay, so far 6, 1 plus 7k plus 7, 1 plus 6k less or equal to -2. Destroy your property, -6 minus 42k plus 7 plus 42k. Can I combine like terms? -6 and 7 gives me 1. Oops, I forgot a k here. Now, this is interesting. -42k and plus 42k, it's 0. And you have something like this. 1 is less to -2. So, this is a problem that has no solution. explain in a second. So think about this. No matter what value of k, so let me take this line over here. Let me change colors. Negative 6 minus 42k plus 7 plus 42k less or equal to negative 2. So you know that this and this will be 0, right? And you're going to be left with negative 6 plus 7, which is going to give you 1. So think about it. No matter what you replace k with, they're both, these two, let me circle them, will give you the same value. And eventually, they both are going to go become 1. So let's say I replace with 2. If I replace k with 2, I get negative 84 here. And if I replace k with 2 here, I get positive 84. And guess what? These two become 0. So no matter what value of k I use, okay, these two will cancel each other out. They'll become 0. And I'm always going to be left with negative 6 plus 7, which is negative 1, and which is less or equal to negative 2. And that's not true. Sorry, positive 1. And that's not true. And because there is no value of k that I can substitute here to make this true, this one has no solution. Negative 2 minus 2x minus 4x plus 5 less or equal to negative 24. Okay, another long one. Negative 4 plus 4x minus 4x minus 20 less or equal to negative 24. Okay, now here I have almost the same thing as the previous problem. So these two will become 0, right? 4x minus 4x. And then I'm left with negative 4 and negative 20. And that gives you negative 24. Now, for this one, it's not a no solution because that sentence, that inequality here is a true statement. So this one is all real numbers. What does that mean? That it doesn't matter what value for x you substitute here, right? I can plug in 2, 3, 4. So think about this. Negative 4, let me write this down. 4x minus 20 less or equals to negative 12. So let's say over here, that x here and this x, let's say I plug in 3. If I plug in 3, I get 4 times 3. I get positive 12. If I plug in a 3 here, right, I get negative 4 and 3. I get minus 12. And it doesn't matter what it is. They still cancel each other out. And those two terms become 0. So doesn't matter what x value we substitute, it will always give me a true inequality, a true sentence here. I will always get this, and it will always work. So, number 22, the answer is all real numbers. Any number you put will work to make that inequality true. 23, 3, 1 minus 2x greater than 3 minus 6x. Distributed property. Oops. 3 times 1 is 3. 3 times 2 is negative 6. Greater than 3 minus 6. Uh-oh. All right, so we have minus 6x and minus 6x. Let's just continue to see what happens. Well, if I get rid of this guy, right, that's end up happening. That becomes 0. I'm left with 3. And this also becomes 0. I'm left with 3. And is this a true statement? Not true. So, because these two, as you can tell, will eliminate each other, okay? It doesn't matter what value of x you put in here, they still will cancel each other out. And this, and then leaving you with 3, which is not greater than 3. So this has no solution. So let me copy that sentence here. So 3 minus 6x greater than 3 minus 6x. So that's what you have. So let's put in a number like 5. Let's plug in 5 over here and plug in 5 over here. You get 3. 6 times 5 is 30. Greater than 3. 6 times 5 is 30. So if you think about it, and I got 3 minus 30 is negative 27, which is definitely not greater to negative 27. So again, let me do it one more time. And this time, let me pick a different number. I don't know, let's pick negative 3 just to be different. Negative 3 for x, and negative 3 for x here. So 3 and negative 6 minus times negative 3 is positive 18. On the other side, it's just the same thing. 3 plus positive 18, we get 21 greater than 21, which is also not true. So it doesn't matter what x value you plug in for x, this, right, the left side will never be greater than the right side. So for this particular number, which I believe is 23, there's no solution. No value of x will make this inequality true. Negative 2, 5 plus 6n less or equal to 6, 8 minus 2n. Treated property, negative 10 minus 12n less than, what is that, 48 minus 12n. Okay, keep getting these type of problems. All right, so again, think about this. We'll do plus 12n. We'll do plus 12n on both sides. That's going to go away, and this is going to go away. So I'm left with negative 10 less than 48. Is negative 10 less than 48? Yes, it is. Now, think about it. Does it matter what value I substitute n with? Well, this will always be true. Well, let me just rewrite this problem, this line over here again. So negative 10 minus 12n less than 48 minus 12n. So let's pick a value for n. Let's pick 4. I don't know, I'm making that up. So let's replace n with 4 on both sides. So here I get negative 10 minus, and I'm going to be times 4. Let me write times 4 over here. 12 times 4 is 48. So on the left side, I get negative 58. On the right side, I get 48 minus 12 times 4 is 48. 48 minus 48 is 0. Is negative 48 less than 0? Yes, it is. So if you have the time, you can plug in different numbers, 4, 3, negative value. It doesn't matter what value you substitute n with. You will always get a true inequality at the end, where the left side is less than the right side. So the answer to this is n can be any all real